Welcome back to Lesson 2 of Swift Fundamentals. To recap, last time we went over declaring variables, we learned how to declare constants, we also learned how to reassign them, we heard about the different types such as ints and doubles, strings, and bools, and we also learned what it means to be strongly typed and how to type annotate. Today, we are going to be seeing comparison operators and logical operators. This way we can learn how to interact with our variables beyond just declaring them. So let's make sure that we've created a playground. I've gone ahead and called it comparison operators. And let's go ahead and create that. Awesome. So we see that we have the same setup as last time. So let's go ahead and get rid of line 3 since we now know how to declare our own variables. And let's start off with that. Let's go ahead and declare a constant and say let number of tickets equal 40. It's a whole lot of tickets. And then let's create another constant, say number of fans. Whoops. And let's say it's 38. Well, here we have two constants, as we've seen before, and we know they're constants due to the let keyword. And now let's interact with them. We are able to evaluate expressions and get a result from it. And for that, we can use a comparison operator. So let's start with 1 right now and say number of tickets. And again, always remember that we have to write things out exactly as they are. We are going to use the greater than sign and then write number of fans. Let's go ahead and run that. And we can see on the side that it evaluates to true. And that's because it goes, okay, well, number of tickets is currently 40. And you're saying that is greater than number of fans, which is 38. And that is a true statement. So it evaluates the true. Now, right now, that true, and you should remember from our last lesson, is a bool. That true, like the result itself, is not being captured anywhere. It's kind of just evaluating it and then just releasing it into the ether. Later on, we will see something like our console further down here, where we can get some output from the computer itself. But this right here, this is a special playground thing where it allows you to see results as they're being evaluated. So we're not really doing anything with that true. So something that we can do now that we know about variables is that we can capture that result into a variable. So in front of it, let's write let result equal this expression. And we can see that if we check what result is, we can see now that it's a bool on the left side here, right? Because it's going to result in some sort of bool. And if we check which bool, we get true. So that true evaluation is being saved in this variable. So we can call it later on. And as we keep building our tools in code, we will see how those results can become very useful to determine what to do with our program. Let's try another one. So we need a variable. Let's start with let result equal number of tickets is less than a number of fans. Go ahead and try to run this, and we get an error. Now in code, we learn a lot more through our errors than we do through our successes, and that's just kind of the nature of the beast. So don't be afraid to try things. Now the reason we're getting this error is because we're declaring the same variable again, and so it says invalid redeclaration. Let's try to remember these error keywords that we see because it helps us identify how to fix them. The problem is that we're using essentially the same variable name again. So let's go ahead and say like result2, and that should solve the problem. And evaluate this. Now we see we get false, and that makes sense because in the background, if we remember, what's actually happening is that we get number of tickets, which is 40, and we're saying 40 is less than 38. And that is a false statement. So you get the bool false. These symbols are called comparison operators, and they allow us to compare things. As we saw before, this is called greater than, And this right here is called less than. You may be familiar with these signs from math class, but if not, you can understand them as you see them, right? They just compare what is on the left side to the right side. In this case, it makes sure that the thing on the left is greater than the thing on the right. Here, it makes sure that the thing on the left is less than the thing on the right. And there are a few more. The next item on our list is called greater than or equal to. So let's create another variable, or a constant actually, and say that's equal to number of tickets is greater than or equal to number of fans. Now, if we run this, we get a true, as we did before with number of tickets is greater than number of fans. 40 is greater than 38. But if we were to change 40 to 38, we can see that this also yields us a true here. It doesn't yield us here because 38 is not greater than 38. But here it says 38 is greater than or equal to 38. And in that case, it is equal to 38. And so we get a true. This is the difference between this and this. So let's keep that in mind. And the next one also works exactly the same. Let result 4, equal to number of tickets is less than or equal to number of fans. And because of the way that it's set up right now, we expect this to also give us a true. Play around with the numbers up above and see what we can get. There are two more logical operators that we need to learn. So let's just keep piling on the results and say result 5. You wouldn't do this in an actual program, but for the sake of this explanation, let's roll with it. And we write number of tickets is equal to number of fans. Now, because of the old numbers that we had, we expect this to obviously be true, because all this operator does is check that the left thing is exactly equal to the thing on the right. Okay, if there's a slight difference, so let's say one of them is 37, we now see that this yields us a false. And of course, there's the last one. Let's say result 6. Let's make a note actually that this is equal to. And the last one is not equal to. And it's written like this. We write number of tickets. We have this exclamation sign equal number of fans. Try to guess what this would actually yield us. Okay, well, if you guessed false, you were wrong. It's true. All it does is that it checks that the left thing is not equal to the thing on the right. And in this case, that's true. 37 is not equal to 38. Now, if we had this as 38, we see that everything gets flipped between these two, right? This one now becomes true, and this one now becomes false. These are the comparison operators. So make sure that we get a good grasp on them because we're going to see them and use them a lot in programming. Our next batch of operators are called logical operators, and we can see how those work. So let's go up here and add a new variable. Say let I am going, or rather it's a constant, and say that it's true because we have 38 tickets and I sure hope we can spare one. And then let's go down here and say let new result, changing things up, clearly going wild, and set that to number of tickets is equal to number of fans. And then we see this new symbol, the double ampersand, and then say I am going. If we run this, we see that we get a true. And that's because this symbol means that the thing on the left has to be true and the thing on the right has to be true for the whole thing to be true. And we know that number of tickets is 38 and 38 is equal to 38, so that's true. So this whole thing, we can write it as over here. We can say, okay, well, we know this evaluates to true. And now that we know the symbol, I am going, which is set to true, is also true. hence our true. The thing to note is that with this symbol and, both things need to be true for the whole thing to be true. If one of them is false, for example, now let's say we change this to 37 and run that again, well, we see we get false because this one right here is false and the next one is true. So false and true gives you a false. And you can flip them and still get the same result, right? So let's go back to 38, change this to false, and see that we get false. And obviously, if both of them are false, well then the whole thing is false. That's the symbol for and. Now, let's go ahead and check what the other one is. Let new result 2, we don't want to get too wild now, and say number of fans is equal to number of tickets, switching it up. And now this new symbol is the or symbol, I am going. Take a moment and guess what you get. And we see that we get true. This is because with the or symbol, one of them has to be true for the whole thing to be true. And in this case, this is yielding true, right? Because 38 is 38. Let's correct this over here. True, and now this is saying false. Okay, so this says 38 equals 38, which is true. The I am going is false, but because it's an or statement, it goes, well, one of them is true, so that's good enough for me, and then sets it to true. So if both of them are true, for example, that also gives you a true because one of them at least is true. Both of them are, but all or is interested in is that at least one of them is true. So in this case, you get a true, and our and statement goes back to saying true as well. Great. Now the last one that we're going to see is a way to flip a Boolean, to flip whatever it is. Meaning, let's say we say here, let new result 3, and call one of our old results. Let's go with the first one, right? We're getting a false. So let's call result. If we run this as is, we get false. But if we have this not, which we've seen before, remember back when we did the not equal to, well, we could put that on variables that are Booleans. We can put that on Boolean expressions, and it just flips whatever it is. So since this is false, this now changes it to true, as we see on our side. And we can try that for another one. Let's say new result 4 equal to, okay, let's get a true one. So result 5. We add the not in front of it, and we see now that what was once true now is yielded as false. That is our logical operators.